So the first section we have is linear functions, and this is the basic equation for a line, which is y equals mx plus b, where m is the slope and b is the y-intercept, and slope is defined by y1 minus y2 over x1 minus x2. Also, slope could be defined as rise over run, or change in y over change in x. And the other equation that we have is called the point slope form, and which is actually two equations. Actually, one equation where you can write it two different ways. The one way is y minus y1 equals m parentheses x minus x1, or the other way is y equals m x minus x1 plus y1, and which leads us to the next thing that has to do with this section, which is parallel and perpendicular lines. And a line is parallel if the slope is the same, so same slope, and a line is perpendicular if the slope is negative reciprocal, so the complete opposite, which can be represented by this equation right here, m1 equals m minus 1 over f2. You can see negative reciprocal, and a graphical representation would be something like this, where let's say this is our equation right here, equals 2 over 3x plus 1, so we just move over 1, and we go up 2, and to the right 3, and this is the basic sketch of the graph. And yeah, that's section 1.3. Next section is functions, and the basic function notation from now on is y equals f of x. And what basically a function is, for every input or x value or domain, there can only be one output. So for every x value, there exists only one y value. And next step is evaluating a function. So let's say we are given this equation, g of x equals negative x squared plus 4x plus 1, and we are given that g of x plus 2. So basically what we do is we plug this in for x, and you want me to go through the
You just show the first step and don't worry about expanding it.
So the first step is x 2 squared plus 4 this is how you set it up, and eventually you get negative x squared plus 5. And another key point to see this graphically, if it's a function or not, is if it passed a vertical line test. So, for example, if we are giving something like this, which is a sideways parabola, all we do is we draw a vertical line, like so, and if it hits if it hits more than 1 point, then it's not a function, because then this means that there's, for every x value, there's more than one value, there's more than one y value, so it does not make it a function. So that's 1.4 right there. Analyzing graphs of functions, which is 1.5. And this has to do with finding the zeros. So let's say we're given an equation like 3x squared plus x minus 10 equals 0. First step is factor, so we're going to end up with 3x minus 5, x plus 2 equals 0, and eventually when we set them both equal to 0, you're going to x equals 5 over 3, and x equals negative 2, and this means that this is the zeros of the, when you graph this given equation. And the next important thing graphically is to see when the function is increasing and decreasing. So let's say we're given f of x equals x cubed minus 3x. The function is going to look something like this. So we just have to say when it's increasing and when it's decreasing. So it's increasing from negative infinity to negative 1. So this is one interval when it's increasing. And it's also increasing from.
Did you say -1?
I said, yeah. Yeah, so this is one interval, and another one would be from 1 to infinity. So 1, infinity, and we have to say when it's decreasing, and this is basically from -1 to 1. So all this right here. So this is when it's decreasing. Yep, and the local min and max in this case, the local min would be -1. Sorry. Yeah, 1, -2, and the max would be -1, 2. So that's for 1.5, and then the next section is 1.6. Just it's called a library of parent functions. So I'm just going to draw all the parent functions because that's what the section is all about. So the first function, the first graph that we have is a constant function, where it's just a horizontal line represented by this, where this equals where f of x equals c, and c is a constant. And the next one that we have is identity function. and that is represented by this right here. And with this line is f of x equals x, and then the other parent function that we have is the absolute value. And this is represented by this graph right here. These are rough sketches of all the graphs and of the parent functions. And this is represented by f of x equals absolute value of x. And the next one that we have is this square root function. And this is represented by f of x equals square root of x. And we still have quadratic function, and this function is something like this, and this would be f of x equals x squared, and f is a cubic function. And a cubic function would be something like this. And this is f of x equals x cubed. And the last one of these parent functions is the reciprocal function. And this one is something like this. This equation is f of x equals 1 over x. Do you want to do the greatest integer function? So those are all the parent functions of graphs. So the section after this explains how we transform these graphs, which is the last section I'm doing.
So Jabber, you only have about a minute for this.
A minute. Alright, so 4 things we need to know are reflections and shifts and reflections, shifts, and reflection, shift,
Stretches.
stretch, yep, and that's it, I think. So reflects over the x-axis when negatives outside parentheses, which is something like this: h of x equals negative f of x. And reflects over the y-axis when negative is inside the parentheses, which is h of x equals f negative x. And vertically along the y-axis can be represented by this: g of x equals c times f of x. And it stretches if c is greater than 1. Yep, and shrinks if if c is greater than 0 and less than 1. Shrinks. So that's stretching and shrinking. And over the y-axis, if c is positive, it shifts up. So c equals positive, looks up. Shifts up.